Today we discuss about parallel combination, right? Now I'll explain how to deal with it. See, we have two approaches when we have a problem. Calculate individual currents in each segment, and then find the net current. From net current, you can find impedance, or else find individual impedances, and then get the what? Tell me, net impedance from that net current. The two approaches are there. Okay, let us continue. What is the point to be understood? See, there will be some current coming in. Obviously, current comes in. The current splits IR and IL. I think most of you already know. Sir, this is simple parallel combination. Huh? Yes, it's simple parallel combination only. Now, when you're adding currents, IL plus IR is equal to I. This is the mistake. Tappu. No. In parallel combination, current will be added. In series combination, voltage will be added. Do you remember that? Yes. But last segment, what we did when we are adding voltages, right? Voltages when we added, did we add it blindly or we added vector addition? We used vector addition, right? Here also same logic. In parallel combination, we need to add current. When we are adding current, we should add according to what? Tell me? Vector addition. Okay. How to add them according to vector addition? Now observe the phases are there, na? This is resistance phasor, voltage phasor. Sorry, this is inductor. This is capacitor. Those phases are still valid. They are still valid only. Okay. But try to understand. In parallel combination, voltage remains same. Okay. In parallel combination, what remains same? Voltage remains same. Current will be divided. So concentrate here. We have to rotate by 90 degrees like this. Because you know very well, voltage will be same in what? Parallel. So actually, this is also getting rotated, right? Hmm. So first you should know how to make the phasor. In this case, think this one like this is like this, VC like this. So you are able to understand why we are rotating phasor, because voltage remains same across the devices in parallel. Okay, sir, good. After that, what to do? Very simple. Once you know what are the devices you have, you make the phasor, superimpose, solve. Now I'll explain this, how to deal with it. First of all, inductor. In inductor, XL is equal to omega L, right? Good. You know inductive reactance, more perfectly speaking. You know inductive reactance. You know what the voltage here, because the voltage across this and this must be same because source voltage. So what you can do is that current in the inductor is equal to voltage across the inductor by reactance, impedance, you can take anything. Yeah. That is equal to, okay, voltage across the inductor V by XL omega L. Remember, in this problem, this V, whatever it is, it remains same because across this, V will be same. Good. I got IL. That means how much current is passing through this. I got it. Now, no need to discuss much resistance. Parallel one is resistance, very easy. IR is equal to VR by R is equal to V by R. Sir, why you are using same V? No need to discuss. I discussed already. They're parallel. It will be same. And that V must be equal to source voltage also. Now you have to add these two currents, because to get the total current, we have to add these two, na? Right or wrong? How to add? Now simply I is equal to IR plus IL tappu. We have to add according to phasor addition. Now we take this, duplicate. Yeah, we take this, duplicate, job done. Superimpose. Oh, did a mistake. What is that? I should take resistance, na? Correct. Superimpose. Once you superimpose, but there is a small point to be noted. When we are dealing with the previous case, check it. We never wrote, check it. We wrote voltage across inductor VL. Source is V. Resistance is VR, VC. But we never wrote IL, IC like that. No, we never wrote because I is same in all these three. Similarly, here also, we are writing VR, check it. VR, VL, not required. We can drop it. This is simply V. Understood? Simply V. Okay, I need to ungroup 1 minute. Yeah. Understood? Simply V. Okay. What next? Now these two currents must be added according to vector addition. So when you add them according to vector addition, the resultant will be like this, right? That is I. And there is a phase angle, phi. Let us move this IR here. Good. Phase angle, what will mean? Phi. Now we can continue. How to calculate I, vector addition? I is equal to IL square plus IR square under root. Point number 1. Next, tan phi. Tan phi is equal to IL by IR. Once you got total current, total voltage, Z is not a problem, right? Z means impedance. Z is equal to total voltage by total current. Solid will get the answer. The core idea is that this is the approach where I took the problem, I calculated individual currents, and I found net current. From net current, I found Z. Check it. That's the approach here, right? For time being, what I'll do, I'll stick to this approach. Impedance approach, I'm not teaching you. Okay. Solve one question. I'll teach impedance approach, second approach. Question number 1. My approach is current approach. Okay. Right. Let us solve. First of all, I'll take phasor. Voltage is V. That is equal to 10. Given there. Now, let us go for resistance and let us continue with the current and resistance IL. IL will be in phase. So, sorry, IR. IR will be in phase. Then IL. IL will be, voltage will be lagging. So, voltage will be leading, current will be lagging. Like this. This is IL. The net will be like this, right? This is the net value. This is I. So, I calculate individually and then I will add according to vector addition. Okay. So, angle between them is theta. Let us continue. So, first of all, IR. IR is equal to V by R. V is 10. R is 5. R is 5. So, it will be 2 ampere. Good. Then, what next? IL. IL. IL is equal to V by XL or omega L, whatever it is. Let us calculate XL. XL formula is omega L. Omega is 10 power 3, 1 kilohertz, na? Into 5 into 10 power minus 3 Henry. Yeah. Kilo and milli gets cancelled. XL is equal to 5. That is equal to 10 by 5. Oh, 2 ampere. In normal circuits, if this takes 2, this takes 2, total how much should come in? Kirchhoff current law. How much should come in? 4. But in this case, no, it's not like that. It is vector addition here. So resultant current I is equal to 2 square plus 2 square under root will be 2 root 2. 2 root 2. That's it, right? Good. We got it. Then what next? That's all. No, we got the total current. And if you want, we can find phase angle also. So I can say phi is equal to 45 degrees. Voltage will lead. And then last thing Z. Z is equal to total voltage by total current. That is equal to 10 by 2 root 2. Yeah, stop it here on 5 by root 2 ohms. 5 by root 2 ohms. 45 degrees, 2 root 2 ampere. I don't know what they asked. Let me read the question first. I calculate everything there, whatever I can. Okay. And inductor, right, fine. Calculate current given by source. Yes, we got it. Phase difference between current and voltage. Done, we did it. Okay. Now, another method also we can do. I gave it to you now. Got it? Calculate individual currents and get the total value. Now, impedance and then. So what to do? Calculate individual impedances. Huh? Okay. Impedance or reactance, whatever it is. Okay. One minute. Concentrate here. In parallel combination, when you are adding resistance or reciprocal resistance. Normal circuits, you know very well, 1 by R is equal to 1 by R1 plus 1 by R2, right? You add reciprocal of resistance, right? Same thing here. Here also we add according to phasor only, but we add with what tell me? Reciprocal. So let us take first thing. This is what? 1 by R. This is 1 by L. No, 1 by XL. And they're at 90-degree angle. And resultant will be 1 by Z. Sir, Purila. Instead of adding a resistance, we add 1 by resistance in parallel, right? Same thing here. 1 by R, 1 by XL, 1 by Z. Of course, angle theta. This is what tell me? This is impedance approach, not current approach. See how I'll solve. I'll calculate 1 by R value. 1 by R value well known to me. What is 1 by R? 1 by 5. 1 by XL also we know, right? 1 by XL is 1 by 5. Now what is Z? What does Z tell me? These two add according to Pythagoras theorem. It will be root 2 into 5 ohms, right? Exactly same value, check it. Now, if you want to calculate current, current is equal to total voltage by total impedance, right? Total voltage is 10. Total impedance will be root 2 by 5. So, therefore, current is equal to 5 root 2. Sorry, 2 root 2, right? 2 times, right? Current is equal to 2 root 2. Check it, same answer you go. Now, phase angle, these two are identical. So, this angle equal to this angle, right? So, we can calculate here also. Here also we can calculate by using tan theta is equal to 1 by 5 by 1 by 5. Clear? That's it. Question number 2. Data is given. Diagram is there. So, let us go through current approach. Voltage. What is voltage? Voltage will be V. That is equal to 2 volt. Good. Then capacitor. In case of capacitor, current will lead, right? Like this it will be. In case of resistance, no need to worry about it. Current will be in phase, right? Good. Current in resistance is IR. Current in capacitor is IC. Angle is 90. Resultant current is I. This is the first part, right? Correct. Now, we need to calculate IR. IR is very easy to calculate. IR is equal to V by R. 2 by 4 is 0.5. 0.5 ampere. So IR is equal to 0.5 ampere. Next, IC. IC. How to calculate IC? For IC, I need XC. XC is equal to 1 by omega C, right? So what is omega? 20 kilohertz. What is C? 25 microfarad. Okay. 20 into 25. Remember, micro is 10 power minus 6. Kilo is 10 power 3. So you will end up at 10 power minus 3. It goes numerator. It becomes 1000, right? This is 50. 2 how many times? 50 times. Wait. 2. I'm getting 2 amperes. Is it possible? Because one is 0.5, one is 2. 1 minute. There's something error there. 25 microfarad, right? 20 kilohertz, 50. Is it right? Check it, calculation.
Sir, I got IC is equal to 0.5, sir.
IC was 0.5. No, 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 no. Wait. 1 by omega C. Omega is 20 kilohertz only, na? Check it.
Yes.
1 by omega. C is 25 microfarad. Just a minute. Some calculation error anukuran. Reason is that generally when I create questions initially, that much deep I don't make it, but there's no option.
Sir, 20 into 10 power 3, sir.
Yeah, 20 to 10 power 3. Okay.
25 into 10
Into 10 power
power
minus 6. Minus 6, right? So it will be 10 power minus 3 in denominator. Go to numerator, it will become 1000, right?
Yes, sir.
That's perfect. I think calculation is correct. No, no error there. There's no error. Yeah, just a minute. Everything is right only. Everything is right. So I can say 25 how many times? 40 times. This is 2. So IC is equal to 2 by 2 is equal to what? Tell me. 1 ampere. So this is 1 ampere. Now observe, this is 0.5. This is 1, right? So squaring and adding, right? Once you do that squaring and adding, you will get, I think, root 5 by 2. Yes. Root 5 by 2 ampere. So angle phi is also a little difficult. Phi or theta, whatever. Little difficult because I don't know. The tan theta is equal to 1 by 0.5 or tan inverse of 2. Theta is equal to theta or phi. Tan inverse of 2. I don't know the value actually. It's okay. What else what they want actually. That is, now we can calculate Z also. Calculate current given with the source. Yeah, we got it. Phase difference between the current and voltage. Yes, we got it. That's enough. If you want Z, you can find Z is equal to 2 by root 5 by 2. It will be 4 by root 5 ohm. That's it. Not required. But once you done the basic this word diagram, everything you can find, right? You can find everything. Good. I want answer for 3. We practiced parallel. Fine. Now, how to add series and parallel. A little bit complex. You may feel, sir, it's same, no, sir. Nothing much serious. No, little problem is there. A little bit of problem is there. Sir, what is the problem? I'll explain. See, when you take the sorry, when you take just a minute. Yeah, voltage across inductor, current across inductor. In this case, no issue because there is no series. Only one element is there. So you can write voltage across inductor VL and current across the inductor IL. This is not a problem. No, no issues. But here comes the problem. Check it. In this case, first we need to go through series combination. In series combination, what happens? Current will remain same. What I'll do is that I'll take current in this is I1. Okay. Current in this is I1 I'll take. Check it. Okay. Then I think I'm committing a mistake, isn't it? Why? First I need to add them. Yeah, good. VR VC. Now resultant voltage will be like this, right? When you have series and parallel like this, then what I'm doing is I'm taking one arm at a time. In this case, no need to worry about it. This is the phasor. In this case, this is the phasor. Okay. So finally, what I can conclude is that when you combine them, ultimately you get 1 minute. You get this. Okay. Right. So resultant current I1 is like this. Resultant voltage across these two. So this entire thing can be considered as a single phasor like this. Now, when you are adding them parallel, you have to add in such a way that you synchronize what? Current, right? No. Parallel case, voltage you have to synchronize. Yeah. Observe. I'll take this. I'll group it. I rotate. No. Yeah, good. And I'll take this also. You know very well, when you combine them parallel, voltage remains same. Okay. So see here series addition. See parallel addition. This is how you have to deal with. Once you got it, you can deal, no problem. What I do is that XL I calculate. XL is equal to omega L. Kilo and milli gets cancelled. It will be what, tell me? Kilo and milli. 40 ohm. Now XC I calculate. Micro is there. Kilo is there. So it will be 1 by 2 into 50 into 10 power 3 here. Numerator 10 power 3. So 2 into 50, 100. 10 power 3. Okay, 10 ohm. XL is equal to 40. XC is equal to 10. Good. Okay. Now, these two are in series. In case of series, what to do? Total impedance Z is equal to 40 square plus 10 square Z1, let us call, under root, right? 10 root 17, okay? Good. Yeah, my blunder is that I added, you're right, XL and XC. Actually, XC and R, na, we have to add for Z1.
Yes, sir.
Yeah, correct. That's what the point is. 10 square plus 10 root 3 whole square. Okay, no need to discuss then. Direct step we can make. 10 root 3 means 30 degrees. Everything is fine. Perfect it is. So it is 20 ohm.
Yes, sir.
Yeah, I did a mistake there. We have to add what? Tell me. XC and R. Answer is Z1. Thank God. This is a very good sign, because if not, it will be a serious problem, right? Okay. Phi is equal to what? Tell me. 30 degrees. 30 degrees. And this phi is equal to 30 degrees. Okay. We can calculate I1 also. I1. I1 is equal to total voltage 20. Total Z is also 20. Is equal to what? Tell me. 1 ampere. So I1 equal to 1 ampere. Okay. Right. What about IL? IL we need to find. IL is easy to find. Current in inductor will be equal to voltage by resistance. In case of inductor, resistance is 40. That is equal to 0.5 ampere, right? Yeah. IL is equal to 0.5. Now, if you can focus, this I can be divided two parts, right? I can divide into two parts. One part like this and one part like this. It's a, I'm not doing anything regarding AC. I'm doing simply vector. If you take this one, if you take the perpendicular one, or y along y-axis, you can say 0.5, it will be 0.5 root 3, right or no? See, this 0.5, 0.5 gets cancelled. Ultimately, resultant current will be 0.5 root 3 only, right? So this is the resultant current. And of course, actually speaking, this circuit is in resonance. Okay. So total resistance, if you want, total resistance Z, total complete circuit, V by 0.5 root 3 means 40 by root 3. Total is 40 by root 3 ohms. Okay. What next? Current, right? Current we calculated. What is the question number 7? Current in the capacitor. We calculated 1 ampere. Okay. Phase difference between total current and voltage, 0 degrees. Total current and voltage, 0 degrees, right? That's it. Nothing else. There you can. So what to do is that you have to add them according to series combination. Then whatever resultant is there, take resultant current, resultant voltage, and phase angle. You add that to what? Tell me. The other parallel one. That's ideal. Okay. So go ahead with 13. Now this is the thing, parallel combination. I guess series also there. First of all, what I'll do is I'll go for series here, series here. First I'll do series. So in series combination, very easy to deal with. Omega L or XL. Start with XL. XL is equal to omega L. Omega is 10 kilo, 10 into 10 power 3. L is 3 root 3 by 2 into 10 power minus 3. So these two gets cancelled. It will be 15 root 3. 15 root 3 ohms. Okay. And R is equal to, in the upper circuit, R1. Upper circuit entire thing 1. This entire thing is 2. Okay. Right. 15 ohm. Now I'm going to make impedance phasor. Series combination, we make impedance phasor, right? Yeah. Inductor will be leading. Resistance will be in phase. Resultant will be like this. This is Z. So I'll call this not Z, Z1. Z1 I'll call. This angle is phi. This is 15 root 3 and this is 15. Obviously phi 1 is equal to 60 degrees, right? We got that. Then what about Z? Z is equal to 30. Simple addition. So I'll calculate I1. Finally, I1 is equal to V, total V. Total V is 12. Total R 30. Okay. So that is equal to I'm getting weird number, but still fine. 0.4, take it, whatever it is. 0.4 ampere. I think it's okay. Right. Next, once you got this, you know very well, in case of inductive circuits, voltage will lead. This is a voltage V. This is a voltage V. And current will lag. And that lagging is by 60 degrees, right? There's a circuit. In upper circuit, I'm telling you, this is the upper circuit. We got it. This is, keep it as it is. This is 0.4 ampere. And voltage is what? 12 volt. Done. Upper circuit is only. Lower circuit, I'm going for XC is equal to 1 by omega C is equal to 1 by, what is omega? 10 kilo. 10 kilo is there. C is 10 micro. So 10 into 10, 10 power 3 will come. Right? So 100, this is 10 ohm. This is 10 ohm. XC is 10 ohm. Then we have to write the phasor because they are in series. No? Series, we have to write the phasor. I'll quickly write the phasor. This is R and this is what? XC. This one, right? Good. So what is the R? 10 root 3 ohm. And X is 10 ohm. And this is Z is equal to 20 ohm. Oh, wait. Same answer. Good. This is what? This is 30 degrees, actually, in this case. 30, because this is 10 root 3, na? And 10 microfarad. 10 microfarad. 1 minute. Am I right? Sometimes I'll take wrong numbers. That's why it happens. Everything is fine. Good. Everything. Now we have to make the voltage phasor. Okay. Observe. In series, current remains same. The finally current and voltage will be like this. This angle is 30 degrees. How to get the current? Current I need to calculate now. So current I is equal to, in the I2 means second, is equal to, voltage is 12, resistance is 20, 12 by 20, 0 0.6, right? 0 0.6. So 0 0.6 ampere. And resistance, sorry, voltage is 12 volt. Done. Now observe, in parallel combination, voltage will be in sync and check it. The upper part and lower part has same voltage. Now what to do? Just copy this. Just copy this and rotate until voltages will be in sync. For reference, I'm making this line. Yeah, for reference, I made this line. Yeah, good. Now it's okay. Rotate done. Yes, perfect. So I need to be a little bit more careful data while copying. This is 12 volt. 0.4. Now to find the net voltage for net current, you can calculate current. What's there in it? Because I is equal to, you can check the angle is 90 degrees. Na? So Pythagoras theorem, 0.6 square plus 0.4 square under root. That's it. Okay. What they want? In the given circuit, calculate current I and current lag or lead by how much angle? This is question number 13. Now, how to deal with it? Current is 0.4, 0.6, right?